Alright, so I've got a new project to work on. It's 2005 Subaru WRX STI, manual 6-speed EJ25 dual overhead cam turbo with a VF39 turbo. Now, this car has come to me with its rear reduction shape for issues with a short block. Has a ringline failure, and I'm gonna try and tell you guys how you can figure this out. Now, what I usually do for ringline failure is the only way to do it is to pull the motor out. You have to rebuild the short block. There's no other way around it. But you wouldn't even know you had it unless it gets extremely severe, or maybe your motor starts knocking, or you lose all compression, and then those symptoms will be apparent, obviously. Now, on this particular car, it actually started with a key issue. A kid bought it before, and as a project, of course, and it wouldn't start. It needed the keys programmed. So he could figure out how to program it, take it to the dealer. I don't know why. He just didn't want to deal with it. Sold it to another guy, and then he ends up bringing it to me and says, "Hey, I need this thing fixed. I'm trying to give it to a family member." So I'm like, "Yeah, sure, I'll take a look at it." I get it, and it's in this shape, and I already know that it's going to be a nightmare. We're looking at motor out, full disassembly, either swapping it, replacing it, building it, and that's where I'm going to kind of go with this. Rebuilding this motor, I mean, you can, but in diagnosing ringline failure, you need to check a couple things out. Now, just much like rod bearing failure, which is a similar deal to repair motor out and rebuild, drain the oil, look for glitter, any type of metallic, gold, silver flake, residue, if you see streaks in it, anything looks out of the ordinary from a black or a conventionally worn oil, then you're going to see that that's going to be a sign of a wear. And you can also do preventative maintenance. Blackstone Laboratories, I would highly recommend you take your oil, put it in a little sample that they send. You get samples for free, and you can take those and ship them off, and they will give you an oil analysis breakdown of what is in the oil, whether it be like zinc or bearing material or aluminum shavings from worn cam journals, and it'll tell you that, and then you can get an idea of how your motor's wearing or where an issue might be. In that case, I would have taken a sample from this car. I would have found a lot of aluminum and a lot of iron, which would have been from the cylinder bore sleeve, which is made of iron, and that'd been from ideally wear in the bore from the ring lands breaking off and causing wear and shaving material to be distributed into the oil pan. The unfortunate deal is that metallic slurry that's generated from the breakdown of those rings, the ring lands, gets into the oil, and the oil isn't recycled into the motor. And so you're looking right up through the pickup, to the oil pump, to your heads, your bearing journals, everything. And a lot of times these Subaru oil filters, unless you're using an OEM or like a Wix filter, which is what I'd highly recommend, if you're using anything else, and even if those filters, even a Wix, those filters still may not have the right bypass pressure. The bypass pressure of those filters is ideally important to keep oil in the filter. If it bypasses, that oil will just leave straight into the block unfiltered, and that's where these issues can come in with your cam timing quits working because there's oil and metal deposits from the oil in your AVCS gears, in your turbo. Your turbo can fail prematurely because now it's getting worn out from all these metal shavings because the bearing surfaces aren't clean. And then you get your AVCS cam timing events is going to work from the oil getting in your gears. Also in the actuators, there's these little actuators about that long. It's on a plug. They're on either side of the motor, and these things can get filled with metal as well and they'll quit working. And they can also be redeposited in. If you rebuild your motor and reuse a lot of these parts, you're just going to get the same issue and contamination again. This is more of an issue with rod bearing failure because the metallic particles are directly from the bearing caps, and then it's much more aggressive. But your ringline failure can be just as bad depending on how long you let it go for. If you are, like in this case, I can't hardly turn this motor over. I had a 3-foot cheater bar on it, and it feels difficult to turn over. And these motors should turn over extremely easy. There should be almost no resistance. It's only 4 cylinders. There's no reason why it shouldn't turn over with a small ratchet. And in this case, it's feeling really really tough to turn over, really aggressive on the bar. It's too much. I'm putting way too much effort. Maybe 25, 40. I don't know. It's a lot of pressure than it should be. It should spin over almost effortlessly. Now I'm rambling. Yeah. So your motor should spin over extremely easy, and if it doesn't, then you've got issues with ring lines. Now don't assume that you got just ring lines. It could be anything. You know, it could be a locked up timing belt. It could be a bad bearings or something wearing like in that area. I've had a motor that has been ran to the point with bearings that it locks up completely until you've removed the whole motor, disassembled it, and take. So you need to do a compression check also. Looking at the compression on each cylinder, 1, 2, 3, and 4, needs to be 150 plus, and they need to all be even. That's more like a gold compression. It should be higher. If it's not, then that's okay. But they need to be even across every cylinder. Unless you're only getting 60 psi across every cylinder, then you're having a rough day. Now, you need to check how easy it is to turn over. If you can feel each cylinder compressing, you get hard, soft, hard, soft, hard, soft as the compression is building and releasing, then you know you've got good compression. If you've got a uniform pull across every cylinder, there's a good chance you're not building compression properly, or you've got something dragging that is greater than the resistance of what it would take to turn the motor up. So if you got some like a dragging piston like this car has, the resistance is equal across the board because you can't feel what would normally be the compression because the resistance of that piston is too hard, and that something's dragging, something's not right, and you've got issues. Now you can check for burning oil. That's a good symptom of premature ringland failures. When you're starting to fail, they'll break, but they won't go anywhere. They'll sit there and rattle around, and you won't be sealing oil as well. It'll be easily seen in a compression test, but not necessarily while you're driving it. And it can happen just from regular detonation. Any issues with bad tuning, make sure you tune with a good tuner. If you don't, you can run into issues like this. This is a stage 2 downpipe intake, intercooler, but stock turbo, stock block. As it looks like it's had a callback to support from the wire coming out of the OBD2 port. And the Cobb stage 2 tunes, even the stage 1s they're okay, but they're not ideal, especially for the long run. You should really think about getting a professional tune on your car from your local tuner for a Subaru and get it adjusted to how your car runs particularly, so you can avoid these kind of issues in the future. Now, to repair ringland failure, you're going to be looking at a few different types of repair strategies. So you can either go ahead and rebuild your block, and you have to buy pistons. It depends how badly worn your block is. If your cylinder bores still have a little bit of cross hatching and it's just premature, so you've not got big gouges in your bore, and you can bring it out with a light hone, then feel free to rebuild your motor with the pistons of the size specs of your block, AB pistons accordingly. Now, if it's a little bit more severe like this one is, where you can feel that the piston's dragging and that there's obvious cylinder damage in the bore, then you have to go to a machining process. We're going to have to take the motor out, disassemble it completely, take the block, send it to a machine shop, have them bored over to 95.5 of some sort, and from that point you can throw an oversized piston in it, most likely a forged, and spend the $700-800 for a set of forged, and then get those sized accordingly to your bore, which would be a great setup. But now you also have to purchase new oil cooler, new ABCS gears, depending on how much oil contamination there was. And you can run it without doing these parts, or an oil pump. So oil pump, ABCS gears, right and left bank, because it's an STI, both gears. And then a lot of times you can just clean out your timing, ABCS timing advanced solenoids on either bank. Just clean them out with brake cleaner of some sort, depending on how bad they are. You need to open them up, push them, actuate them, take a little pry tool in there, clean them out really well, clean the screens, and replace all of your banjo bolts for your oil feed on the passenger side turbo. So there's a bank of, and the driver's side too, there's oil feed lines that come off the block head on either side, and they feed to the AVCS advanced solenoids. You need to take those off, or at least the banjo bolts, and replace those or clean them out as best as you can. Without doing that and they get clogged, you're going to have cam starvation issues, and you'll be replacing a cylinder head before you know it. It is also known on these cars to cause issues with the turbos on the driver's side, or passenger side head. You can get cam codes for your passenger bank and they don't go away. A lot of times it's due to an plugged oil restrictor valve or a failing turbo that's no longer holding back oil pressure. So replacing these banjo bolts can give you a premature or maintain the vehicle ahead of time before it breaks. Preventative maintenance is what I'm really trying to say. And replacing this before your turbo fails. These are just little things you need to do before you put the motor back in. Throw the motor back in. So you have the AVCS gears, both left and right bank, your oil pump, your main bearings. If you've got metal in there, you need to replace those with either a standard type and spec them accordingly to whatever shop would like to do it, however they like to do it, or you can do it yourself using plastic gauges, but you may not be as accurate. But I've done it that way and I've had great success. It's worked as long as your bore is straight and you don't have any scoring on your crankshaft, and you can use a standard size bearing and everything will be fine. And check your cam caps. A lot of times the cam caps, even on bearing failure or any type of metal contamination, a lot of times, again, when I said those banjo bolts filled with oil, any type of oil starvation issues on these 2.5 liter motors with any AVCS, you can run into issues with starvation in your cam caps. And you can see obviously as you remove the cam caps that there will be grooves or lines in the cap journal or on the crankshaft itself, the camshaft itself. The camshaft is a hardened steel, so it's not like it's really going to be too bad. It's the aluminum journals in there that are going to take the most damage, and you can see that. A lot of times, if they're not lightly damaged, you can come in and polish them up lightly and be fine. You can maybe run a little thicker oil if you like, but I wouldn't go anything over like a 40 or 50 weight. Just to be kind of safe if you're running a stock bearing clearance on these cars. Well, maybe like a 40 weight actually. I don't like a 40 weight. 30 or 40 should still be fine. Just don't run anything like a 20 weight if you can really help it. 20 is really thin, especially if you're in a really hot climate. And then the oil cooler. The oil cooler is full of small veins, small holes that you cannot clean out. You need to replace it or delete it. All that oil cooler does is help warm up your engine oil and coolant when you're trying to start up in the morning. That's all it does. I've deleted them. They're not on half the cars. They're not even on the newer 2011s. Okay, they're not there. They're not needed. It's a waste of money. You can just plug it off. Doesn't matter. Promise. Now, what I'm gonna do particularly on this car is, since it's for a friend, he wants to kind of build it, or at least for the future. But I'm trying to do it on a reasonable budget. I'm not trying to dump $5,000 into this car. That's too much, especially for one that's got no mods yet. So if you're gonna keep the 2.5 liter, try and buy a used lower mileage block, either from a 2004 to 2007 Forester XT, the Legacy GTs, or Outback XTs, and the WRXs from 2006 and up to 2014. Those will all have a motor that will fit. Yeah, EJ255 can have different revisions of those. They have the 255 and 257s. The earlier models from 2004 to 2006 all used an EJ257 style block with pistons. I think those are a D25 or I think those are a B25 casting actually, for a cylinder head, and the pistons will be according to that. They're going to have a slightly lower compression ratio. Now on the EJ255s in the newer years with the emissions, with the secondary air pumps, those are all going to have a D25 head, if I'm right. I could be wrong, don't quote me. But it's going to have a lower compression head, or higher compression head, with a more aggressive piston. Now, I'm fairly sure the pistons are all the same. I can use an STI piston or a WRX piston interchangeably. The rods are all the same. Only the 2.0s were a little different on the pistons, but the rods are still the same. That's the only thing different is the crank on the 2.0. The 2.0s don't have this issue on the earlier WRXs because the pistons are smaller, they're not as thin, their area of detonation is smaller, and the it's not really much of an issue. So anyway, hopefully that helps.